In the last video, we actually saw about a question of finding DFT. So the question was find 4-point DFT of x of n 1, 2, 3, 4, and we got the result as x of k is 10, minus 2 plus 2j, minus 2 and minus 2 minus 2j. Today we are going to do another one problem regarding IDFT. So IDFT problem, we are going to solve it, and basically you are expected or you'll be given x of k. Let us do the same question so that you get an understanding of how the result will be. So the result would be like to be obtained is 1, 2, 3, 4, exactly like if x of n is converted to x of k, you get this. If x of k is given, then you have to get the result like this. So we'll try solving this particular problem. Find 4-point IDFT of x of k, 10, minus 2 plus 2j, minus 2 and minus 2 minus 2j. Now again, you know about the formula that is to be implemented. So x of n is equal to 1 by capital N summation k equal to minus infinity to infinity x of k e raised to my plus j 2 pi nk by capital N. So please note here there are few changes compared to the other formula. You have a 1 by n. So when we look at this particular concept, you can understand a resemblance between the original Fourier transform formula. So we knew that your inverse Fourier transform formula will be given like 1 by 2 pi integral minus infinity to infinity x of omega e raised to j omega t dt. So just like the concept of your inverse Fourier transform, it can be applied to inverse discrete Fourier transform. So x of t becomes x of n, which will be obtaining naturally. Now if you remember, I had told you that in your continuous Fourier transform, the resultant signal is periodic over the interval 2 pi, and we are creating discrete signal of that. It means this sample space between 1 to 2 pi will be containing n samples. That is a concept with which we had analyzed the discretization of a continuous frequency signal. So this 1 by 2 pi is analogous to 1 by n. So 2 pi over here refers to n samples in the discrete form that is available in the span of 2 pi. K equal to minus infinity to infinity x of k e raised to plus j 2 pi nk by capital N. So that is the idea conveyed over here, and using this formula we will have to start solving our problem. But before moving ahead, we need to have a concept of what is n, what is k, and what is capital N. So if you remember in the previous case, I had told you that n represents a range of position of samples in x of n, and this k represents range of position of sample in x of k, and n represents the total number of samples at output signal. So here in this particular IDFT problem, your x of n is the output signal, your x of k is the input signal, and your output signal again refers to x of n. So we can understand from the question that about these three parameters. So k is already given to you. K is given to you as containing 4 samples over here, 10, minus 2 plus 2j, minus 2 and minus 2 minus 2j, which will be positioned from 0 to 3. So your range of k will be 0 to 3. Your capital N will be 4 because you are asked to find out 4-point IDFT. So your capital N will be 4, and hence your range of n will be from 0 to 3. The usual concepts, nothing wrong except for the fact that here there is a reversal in the signals in terms of input and output perspective. Now we'll try to solve this particular problem. Okay. Now as we move ahead to solve this particular problem, we know the formula x of n is 1 by n summation k equal to minus infinity to infinity x of k e raised to plus j 2 pi nk by capital N. Now as you already know, k will be spanning from the space of 0 to 3, n will be spanning from the space 0 to 3, and capital N will be spanning from 0 to 4. So as you look at these formulas, you can see that the first thing that we are supposed to find out, or the x of n will be expected to contain 4 samples, which will be moving from x of 0, x of 1, x of 2 and x of 3. So these are the 4 samples that we need to find out. So we'll start off with x of 0. So x of 0, when you try to apply it to this formula, it becomes 1 by 4 because n is equal to 4. Summation k here is spanning from 0 to 3. So 0 to 3. X of k e raised to plus j 2 pi nk by capital N. So moving ahead, we can see that it becomes 1 by 4. Summation k equal to 0 to 3. Now when we consider the position of n equal to 0, when we substitute it over here, the entire e terms become e raised to 0. So it will become 1. So this is equivalent to x of k. So for finding out x of 0, there is not much of an issue. Just like we had applied in the form of DFT, your first term can be treated as the sum of the entire signal available. So x of 0 is 10 plus our next term is minus 2 plus 2j plus minus 2 plus minus 2 minus 2j. So this was the resultant sum of the signals. So it is 1 by 4, 10, minus 2 plus 2j is minus 2 plus 2j minus 2, and when we open the bracket it can be written like this, minus 2 minus 2j. So as you see over here, this minus 2j and this can get cancelled and the remaining terms remain intact. So 1 by 4, 10 minus 6 it comes, so that will become 4 by 4 and you get the answer as 1. And the x of 0 was expected to be 1, and now you can see that we have got that answer. We'll do one more example of solving x of 1 and x of 2 and x of 3 have to be managed on your own as a trial for the particular example. You know that the answer will be 3 and 4, so you have to find out the answer. So for finding out x of 1, we need to use this particular formula again. Summation k equal to, here it is 0 to 3, x of k e raised to plus j 2 pi nk by capital N. Now you can see that if we have substitute 1 for the value of n over here, you can see that it can be written as 1 by 4 summation k equal to 0 to 3 x of k e raised to plus j. Now since n is 1, it will become like plus j 2 pi into 1 into k by 4. So it will be like 1 by 4 summation k equal to 0 to 3 x of k e raised to, when we cancel out this 2 and 4, it becomes 2. So it will become k e raised to j k pi by 2 as already seen earlier. Now when we expand this particular formula with substituting the value of k, you can see that it can be written as 1 by 4. When we substitute the value of k, it becomes capital X of 0, and when k is 0, this becomes e raised to 0, so it becomes e raised to 0 equal to 1, so it can be written as x of 0 itself, and x of 1 is there into e raised to j pi by 2 plus x of 2. When we substitute k equal to 2 over here, it becomes e raised to j pi, the 2 and 2 gets cancelled, plus x of 3 e raised to j 3 pi by 2. Hope you have got this. And to solve this particular thing, we need to apply a concept that we had learned earlier. We learned in the previous session that e raised to minus j theta is cos theta minus I sin theta, and here we have to apply e raised to j theta, so which will be equal to cos theta plus I sin theta. When we apply this particular concept over here, 1 by 4 x of 0 x of 1 cos pi by 2 plus I sin pi by 2. plus x of 2 cos pi plus I sin pi plus x of 3 cos 3 pi by 2 plus I sin 3 pi by 2. So when we solve this particular thing, moving ahead, we can see that this becomes x of 0. Now x of 1 is x of 1 will be there. Cos pi by 2 is 0 and I sin pi by 2, sin pi by 2 is 1, so this becomes I plus x of 2. Cos pi is 1, so this will become 1 itself, minus 1. And plus x of 3, it will become sin 3 pi by 2. This will be equal to minus 1 and this will be 0, so it becomes minus I. So now when you expand this particular formula, we get it as 1 by 4, x of 0 is 10 and x of 1 is minus 2 plus 2I into I plus x of 2 was minus 2 into minus 1 plus minus 2 minus 2I into minus I, it's there, and this will be equal to 1 by 4, 10, that will be minus 2I plus 2I square, meaning okay, 10 minus 2I, and the other term becomes 2I square, which will, I square will become minus 1, so it will become minus 2, and this will become plus 2, and over there you will have, when you open this particular bracket, you will have plus 2I, and then you will have minus 2I into minus I, which will become plus 2I square, which will become minus 2. So eventually you will be having these two terms cancelled, you will have these two terms cancelled, and at the final you will have 1 by 4, 10 minus 2, which will become 8, and hence it will become 8 by 4 equal to 2. So as you already know, x of 1 was expected to be 2, and similarly you will have to solve this problem in the similar manner and find out the answer for x of 2 as well as x of 3, where x of 2 should be equal to 3 and x of 3 should be equal to 4. Now you will have to solve this particular thing and find out the answer, and hope you can complete it, and hope the method is also clear. Thank you.